Hello guys, welcome back to a new video. In this video, I will show you how to basically calculate the power requirements, for a MX480 chassis. So I have a customer, and he basically sent me all components, to build the chassis. But he told me that for them it's very important, the power consumption of the whole chassis. That is a big deal for them. So uh, based on that, I will help the customer, to calculate the total power based on different components that are installed on the chassis. So basically the chassis is divided by two different zones, SB control 0, SB control 1, MPC or DPC 0 or DPC 1. That's the zone 0. And the MPC, DPC 2, 3, 4, and 5, they are basically, the zone 2. So basically, every single of the component that are installed in the chassis, they consume, certain amount of watts. So basically based on that, my customer told me I need to know exactly, what will be the maximum power consumption on the chassis based on the configuration. So let me show you how to do that. So I have a chassis. I will show you the chassis right now with all line curves, and then on Juniper network we have a tool that is a power calculator, and then we goes there and enter every single component on the chassis, just to help me to determine the amount of power. So basically, right here, for example, we have the chassis MX480. We goes there, and then we from here, as you can see, power zone. Basically, we have MPC2, MPC3, MPC4, and MPC5. So basically, that's the zone number 1. Right here we have base chassis, system. We have another area right here, which is basically the fan tray. Some components on the some line cards, they require high capacity fan as well as high capacity power supply. So basically, we have the zone 1 right here, which is basically from a slot SBC 0, SBC 1 or control board, MPC 0, and MPC 1. That is zone number 1. So let's start adding the components to the calculator in order to get all information that the customer wants. So basically we go here and select the power supply. So power supply, we have high capacity AC power. This is a 2500 watts power supply for sure, yes. And redundant, yes, we need redundancy in this particular chassis. The input, the output input, the power input on the voltage, basically we have 220 volts. There we go. So on the control board we have SBC. We have basically the SBC2 plus one routing engine, which is the RE18X4. So basically the SBC is consuming about 180 watts, and the routing engine is about 90 watts, if I don't remember. So let's, it's an SBC2, sorry, this one right here. That's on the control board 0. The same thing on the control board 1, because there is a redundant routing engine on the system. So basically on here, on the MPC 0, I have one particular card, which is this one right here, the MPC 3D 16X, which is a 16 port 10 gig. And then we have on MPC 1, we have this particular right here. We have an MPC 4E3D 2CGE-AXGE. So we have 3 of these modules. So this is basically the zone 0. We have all the line cards already defined on the zone 0. So let's go to the zone number 1. So the zone number 1, we have a fan tray, which is high capacity fan right there, 160 watts. um, so on MPC2 I have the same car, the same MPC4E, which is this one right here. On MPC3, MPC3 I don't have. One second. On MPC3 I don't have nothing. So MPC4, yes I do. I have the same line card. And then I have the MPC5, I have the same line card as well. This one right here. So basically we have right there the whole configuration that my customer wants. So, and here we can see right here, all the maximum power that is consuming for all systems. So basically, look at right here. I entered the information about the power supply. I had 2500 watts power supply, and I entered all the line cards on the model, and the system recommend 4 power supply, 4 of them. So basically, the power supply, I show you later the power supply. So basically, we have here, all the power. That's the information that my customer need. Why? Because probably they have an interrupted power supply or UPS, which is a battery. So they have maybe some component or some equipment, on the unit, and they plan, to install this chassis right there, and they want to make sure that the consume of watt doesn't exceed the capacity of the battery in case of a loose powers, or voltage. So basically, right here I have all this information right here, so I can download that. This will create a document, and then the document I need to send to my customer. So the PDF right here, or you can Excel if you want to, but in this case the PDF. Right there. So I have this here. I open the document. Look at that power calculator, and then you can go here and check all the information. For example, this is the MPC5, the line card that we have on the chassis right here. They consume 565 watts every single model. And the song number 1, look at that, the base chassis. On song number 1 and 2, the high fan capacity, I believe they have the high fan capacity is deducted from the total power consumption. I don't know why, but on the song 0 on MPC1 we have the same line card, the MPC4E, and on the MPC0 we have the MPC3D16. And then we have 2 routing engine, which the total amount of power is 245 and on each switch control board. This includes the routing engine, of course. So that is the document right here, guys. Look at that, PEN, power supply high capacity, redundant, yes. And then there is some more information regarding that. The maximum total power draw is at 3,790 watts. So that's what my customer, that's the information that my customer needs, and it's a very important, check all these environmental, condition on the chassis, just in case. Sometimes, when one line kind is not working properly, and needs an overheating, the fans increase the speed, in order, to stabilize, the heat capacity, the BTUs. So that's why very important, to estimate, and this tool is very, very crucial for get that information. So once I have this document, I send it to my customer. So now let me show you the chassis. I will connect all line cards in there, and we execute a few power commands, just to make sure, what is the total capacity. Maybe, we can get, the same information that we get from here. So let me connect the line cards. Let's connect all the power supplies. We have 4 power supplies on that. Because 2 power supply basically working together, pen 0, pen 1, pen 2, and pen 3, and basically the 2 of them can cover the total watt capacity. But the problem, the thing is, the other couple power supply, they are working as redundant power. In case this power supply fail, they can compensate, the amount of power demanding on the chassis and all components. So let me connect the chassis, guys. So right there we have the chassis, guys. So this is the line card right here. So I will, basically, insert these line cards based on the configuration that we already discussed, right? So the MPC480 goes into the slot number 5, or MPC 5 right there. So let's connect it. Let's insert the module. So this is the other one right here, which is basically the same thing, MPC480. Right there. So we have the another MPC on a slot, MPC slot 0. Remember the zone, right? SBC control board 0, control board 1, MPC 0, and MPC 1. This is zone number 1. And this right here, from 2 to 5, this is the zone number 2. So let me set the other line card. And now the 16 port card. So basically that's the chassis. That's how do you build the chassis, based on, the very important, to determine, how do you want to divide, the power consumption between zones. And then you hit the power supply. Here is the power supply, the 25 watts, 2500 watt power supply, 220 volts input, right? Sorry, right there. So basically, so let's power the router and make sure that everything is booting and all the environment fan power are working properly. And then we are running a few commands to check, the power consumption on the chassis. So let's power this on. This is a very noisy, chassis. So I have, so this is a, I'm sorry about the noise, but we have to power this on. Console cable. So let's wait until the unit complete boot in order to check the commands about the power and the environment. So guys, basically the chassis already boot, and let's show just check run a few diagnostic command show system information. Show chassis, hardware detail, just to make sure the components installed on the chassis. So basically, well, so look at that. I have the chassis MX480. This is a BP3 chassis, and I have 4 power supply. I have the routing engine 0 on control board 0 right there. I have the other routing engine as well on control board 1 right there. So, and I have the 2 enhanced SBC switch control board 0 right here, control board 1 right there, or it's lot 1, 0 and 1, of course. So on the FPC or the MPC0, I have the 16 port card right there, right, which is the bottom one, this one right here. So I have basically this one comes with the 4 FPCs, each FPC is divided into the four 10 gig ports. So basically, as we can see right here. So on MPC1 or slot 1, I have this the MPC4E line card right there, which is basically this one right here, 2-port 100 gig card, and the other one 8-port 10 gig. 10 gig. Basically, I have the same model on FPC3 right here, and I have some optics as well. FPC 100 gig LR4. And FPC5, I have the same line card right there. So basically, that is how that is working. So show chassis FPC peak status right there. Look at that. All the line cards are up and running. Right there, the MPC, the slot 0, the slot 1, the slot 3, and the slot 5. And this is the peak status on each one of them. So this is very important information about the line cards on the chassis. If there is if one of the cards that are not online, there is a problem with the module. So basically, show chassis environment pen 1, for example, pen 0 to check the 0 power supply, 1, 2, 3. We can also check the control board, switch control board. CD. This is the 0 slot, right? And this is the, we can specify the slot number, I guess. 0? Yeah. And the slot number 1. Right there, we can also execute show environment routing angle. Look at that. And that very important information, regarding the temperature on the unit, because there is some parameters in there that the engineer can set in order to to trigger an alarm when one of these parameters exceeds the heat capacity. So very important in there. So another command is show chassis power, and right there we have all the power information, all the power, the capacity, total capacity, the allocated power, the actual use, right? And if we can see right here, we only we are just the comment just estimate the consumption on the zone 0. Why? Because the other two power supply are redundant. So in case that something happened with power supply 0 and the other remaining power supply start to supply the power in watts to avoid that any of those module goes down for sure. And basically, guys, and show power detail and show chassis environment, of course. Important to check all fans. I mean, this particular chassis, there is not only the high-speed fan, which is located in this part of the chassis right here. There are also fan on power supply, and that is very important to check if all these fans are basically working fine. If there is any problem with the fan, this command will tell you exactly, look at that. Show chassis alarm. And then there is 2 alarms, but that is not the deal. As you can see the chassis, on the chassis you can see, one red alarm right here. This is power supply, fans, routing engine. Basically, but this alarm is because the Ethernet port on the routing engine, they are not connected. Let's clear the alarm by connecting, the Ethernet, the power cable, the Ethernet cable. One and two. Wait a few minutes, maybe a minute, and that will clear the alarm, basically. There we go. So guys, this is how you basically estimate, the type of power supply that one chassis like this, required based on the configuration on the line card. This one consumes, a specific amount of watts. This one as well, this one as well, and all the chassis, all the chassis is very important to check and send this. I have this document ready to send to my customer, because he needs the information. It's very important for them, to estimate the total amount of watts of the chassis. Thank you so much for your time, guys. I really appreciate it, and I will see you in the next video. And if you like the video, please subscribe to my channel. Give me a like and share with your friends and coworkers. Thank you so much, and have a good afternoon. Thank you. I will see you in the next video. Thanks.